Now we have seen first part of instrumentation of IR spectroscopy. This PPT slides contains instrumentation of infrared spectroscopy, in which first part is infrared radiation source and second part is monochromator. Now we have seen instrumentation of IR spectroscopy. The following are the essential components of an infrared spectrophotometer, in which first light source, second monochromator and optical materials, third sample holder, fourth detector, fifth recorder. We have seen one by one of these instrumental parts of this instrumentation of IR spectroscopy. Now we have seen first part, means light source, that is also called as infrared radiation source. The infrared radiation sources are the hot bodies continuously emitting the radiations which approximate a black body radiator in their emission properties, in which first radiation source is incandescent lamp. A closed wound nichrome coil can be raised to incandescence by resistive heating. A black oxide film formed on the coil gives acceptable emissivity. In this, the temperature can be reached up to 1100 degrees Celsius. The nichrome coil does not require water cooling. It requires little or no maintenance and give long service. This source is recommended where reliability is essential. Though this source is simple and rugged, it is less intense than some other infrared radiation sources. Now we have seen second infrared radiation source is near-nest glower. In IR spectroscopy, near-nest glower is the most commonly used source of radiation. It is constructed by fusing a mixture of oxides of metals like zirconium, yttrium and thorium. They are molded in the form of hollow tubes or rods about 1 to 3 mm in diameter and 2 to 5 cm in length. The ends of the rods are cemented to short ceramic tubes for mounting, and short platinum leads are provided for power connections. Third radiation source is globar source. It is a rod of sintered silicon carbide 6 to 8 mm in diameter and 50 mm in length. It is self-starting and is electrically heated. The operating temperature is about 1300 degrees Celsius, means 1300 degrees Celsius. It has a positive coefficient of resistance and can conveniently be controlled with a variable transformer. Now, fourth radiation source is Mercury Arc. In the very far infrared region, that is beyond 50 micron, means 200 per centimeter, black body type sources lose effectiveness as their radiations decrease with the fourth power of wavelength. Mercury arc gives intense radiation in this region. It is enclosed in a quartz jacket to reduce loss. And last radiation source is tungsten filament lamp, in which this source is useful for near infrared region only. Now we have seen second instrumental part is monochromator. The radiation source emits radiations of various frequencies as the sample in infrared spectroscopy absorbs only at certain frequencies. It is therefore necessary to select desired frequencies from the radiation source and reject the radiations of other frequencies. This selection is achieved by means of monochromator. The monochromators are of two types. First is Prism Monochromator and second is Grating Monochromator. Now we have seen first Prism Monochromator. These are favored because of greater range and simplicity. Neither glass nor quartz is sufficiently transparent to infrared radiations, and therefore other materials like halogen salts are used in prism monochromator as they are transparent to infrared radiations. Quartz prisms are used only in the near infrared region. It is absorbed strongly beyond 4 micron. The bulk of analytical work in the infrared region is done using crystalline sodium chloride as the prism material. In the infrared spectrophotometers, the focusing of the radiations is achieved by using concave mirrors rather than prisms. These mirrors can be prepared from various materials like metals or glass coated aluminum. The main advantage of these materials is that materials have no chromatic aberration and are sturdy. Besides concave mirrors, plane reflecting mirrors are also used. The prism monochromator may be a single pass monochromator or a double pass monochromator. Now we have seen single pass monochromator. The sample is kept at or near the focus of the beam just before the entrance slit to the monochromator. The radiation from the source after passing through the sample and the slit strikes the off-axis parabolic lithomirror. This renders the radiation parallel and is transmitted to the prism. The dispersed radiation after reflecting from a plane mirror returns through the prism second time and focuses into the exit slit of the monochromator and then to the detector part of the instrument. Now we have seen double pass monochromator. In the double pass monochromator, there occurs a total of 4 passes of radiation through prism as shown in single pass monochromator. The double pass monochromator produces more resolution of radiation than single pass monochromator. In both single and double pass monochromators, sodium chloride means rock salt. Prisms are employed for the entire region from 4000 to 650 per centimeter. Prisms of lithium fluoride and calcium fluoride give more resolution in the region where the significant stretching vibrations are located. Now we have seen second type of monochromator, grating monochromator. The grating is essentially a series of parallel straight lines cut out into a plane surface. It is usually constructed from glass or plastic which is coated with aluminum to minimize greater amounts of scattered radiations and the unwanted radiations of other special orders. The gratings are blades to concentrate the radiations into a single order. Thank you.